Hello everyone, my name is Ouyang Yuling, the author of this paper, from the Shanghai Advanced Research Institute of the Chinese Academy of Sciences. Next, I would like to introduce the machine learning enhanced CPU-GPU simulation platform for 5G system to you. My introduction is divided into the following 5 parts. Background, 5G system simulation parallel framework. Proposed classification, 5G system level simulation evolution and conclusions. First, let me introduce the background of the paper. The main purpose of this paper is to solve the problem of 5G system simulation. In the EMBB scenario, the layered heterogeneous network architecture will bring more complex topology structure and more intensive data operation to system simulation. Conventional CPU serial mode applied to 4G system level simulation has obvious disadvantage of low efficiency, which cannot meet the requirements of 5G system level simulation. Motivated to greatly improve the simulation efficiency, we propose a method of introduction machine learning to optimize the allocation of compute resources for CPU-GPU-based parallelization simulation platform. The following is Marnie introduced the 5G system simulation parallel framework. The design of the whole platform includes 2 parts: 5G system simulation framework design and resource parallel architecture design. In order to efficiently design and implement 5G simulation system, it is necessary to define, analyze the characteristics and implementation schemes of various application scenarios and candidate technologies. In figure shows the parallel architecture and parallel simulation analysis process. To meet the simulation requirement for large-scale node deployment and mass data processing in 5G system simulation, the platform adopts distributed CPU-GPU heterogeneous parallel architecture to solve intensive computing simulation in the resource parallel architecture design. The CPU has been characterized as strong single-core processing capacity and fast computational speed. It is a benefit for complex logical operations. Single-chip GPU usually has thousands of stream processor cores. Its single processing float point computer power is 10 times higher than CPU, which is suitable for data parallel processing brought by hundreds or even thousands of nodes accessing in 5G system. Multiple CPU parallel solution can improve the computational and processing ability of simulation platform to a certain extent, but unlimited results circumstance how to make full use of the computer capacity to achieve the maximal simulation efficiency is a key issue. Next, we will introduce the classification scheme and the parallel gain analysis evolution mechanism. Due to the difference in CPU and GPU performance, logistic regression algorithm in machine learning is considered to classify parallel computer modules. This means that an existing symbol space is necessary for us to apply logistic regression algorithm to determine whether a program module should be run on CPU or GPU. We define the fitting function, put the relevant parameters that affect the running time of the simulation system into the fitting function, and use the corresponding parallel mechanism to judge. The influencing parameters include the number of macro stations, the number of macro base stations, the number of tuners, the encoding modulation mode, and the corresponding weight value. On the design of 5G system simulation framework, we have adopted the dynamic modeling technology, layering and modeling the network, analyzing the dependencies between the inter-modules of the program to decoupling the program. The goal is to solve the coupling between the conceptual model and the implementation. We evaluate the computing time, the preparation time, the execution time, and the processing time to accurately evaluate the gain of parallelization. Modeling technology is also the foundation of quantitative analysis methodology. Through the parallel optimization mechanism, we optimize the 5G system simulation platform. Next, we introduce 5G system level simulation and results evolution. The simulation scheme adopts macro base station and micro base station joint deployment mode. Our platform is configured according to the parameters in the table. If you set related parameters such as the number of cells, number of users, number of antennas, and base station, and so on, the platform automatically selects the CPU or GPU mode. We first introduced the 5G system level simulation program used to verify CPU-GPU heterogeneous parallelism. The output of the 5G system level simulation program is the throughput of the system in both serial and parallel simulations. Comparing the edge throughput and average throughput of the two simulation modes. The results of serial simulation tend to be consistent with those of parallel simulation, and the error is merely related to some random processes in the program, such as noise and other factors. This demonstrates the reliability of our parallel computing platform, which is comparable to traditional simulation platforms in the accuracy of simulation results. And three simulation scenarios. The curve of time duration changing with the number of base stations is almost linear, but it is clear that the gradient of the CPU serial scenario is much higher than the gradient of the other two scenarios. Our parallel simulation scenarios consumes the least amount of time. Our parallel simulation platform has more obvious accelerate effect compared with CPU parallel simulation. Finally, I will introduce the conclusion of this article. The system-level simulation platform is mainly used for 5G key technology research and application verification, and can also be extended to 6G system simulation in the future. System-level simulation in 5G scenario has become significantly important for the research of new technologies in communication industries. However, large-scale system-level simulations commonly lead to high computational costs, which make efficient implementation of targeted simulation of 5G application scenario training tasks. To tremendously shorten the execution time, we proposed to develop the CPU-GPU-based parallelization platform. In particular, the proposed platform adopts logistic regression algorithm to classify parallel modules for optimize the use of computational resources. The simulation program and 5G system-level simulation is used to verify the validity of the platform. The metrical results demonstrate the effectiveness in terms of reduced execution time and guaranteeing reliability of system-level simulation results in 5G scenarios. It also provides an effective means for future 6G system simulation. Thanks for your attention.